Hey guys, so I just want to talk about a little application of how rational functions can appear in the real world. In the beginning this week, we looked at several examples of how they can appear. In this example, I want to take a scenario, a real world scenario, and apply graphing and asymptotes to the example a little bit deeper than we did in the beginning of the week, just to kind of make it all full circle. So let's read this example here and chat about it. So it says that a virtual reality headset allows users to experience video games as immersive three-dimensional environments. Suppose that Apple has a fixed monthly cost of $600,000 for this invention and that it costs $50 to produce each headset. So just some numbers they were throwing at us. The main question is right here. What is the horizontal asymptote for the graph of the average cost function C of x? Describe what this represents for the company Apple. Okay, so we know the cost function. They gave us all the information right here. The cost function is the sum of the fixed cost and anything that's going, the variable cost, anything that's going to change depending on how many headsets are made. So the cost function is right there, 600,000 plus 50x, our fixed cost for any bills Apple has, and then $50 times 50 times x. X is the number of headsets. If they sell one, if they produce one, or if they produce 100, would go into that x, the variable. Our average cost function. Well, we know how to find averages, right? You add up all of your items divided by how many items there were. So we don't know how many headsets are going to be produced. So we have our cost, 600,000 plus 50x divided by x. X represents how many are produced. We're going to keep that as a variable x because this is a function. We could substitute any number into the function and figure out the average cost for that many headsets produced. Our main question then is, what's the horizontal asymptote? We've spent all week trying to find horizontal asymptotes. We are going to use our function here to find a horizontal asymptote. We know our numerator degree is 1. Our denominator degree is 1. When they are the same, we use the leading coefficients. So our leading coefficient of the numerator is a 50 over the leading coefficient of the denominator is a 1. So our horizontal asymptote is y equals 50. So let's check out what that looks like on the graph here. We can graph this, and there's what the graph looks like. You can see they only graph part of this curve. We all know the other part is over here, right? Just like we spent all week graphing them. So we're only looking at the first quadrant there. We can easily see here's our horizontal asymptote. The graph approaches this line, y equals 50, doesn't ever touch it. So what does that mean? Okay, if we think about it, our x-axis, and that's what is really helpful to find out when we're trying to represent the horizontal asymptote, is to make sure we know what the x and the y-axis represents. So our x-axis is the number of headsets produced per month. Okay, that's this variable we've been talking about this whole time. That's how many headsets are produced. The y is the C of x, our average cost per headset. So notice this means that the more headsets produced each month, right? It could be 8,000, it could be 48,000. As that gets increased, the closer the average cost per headset for the company decreases, comes closer to $50. So at 8,000, our average cost would be at about 125. Okay, at 40,000 headsets, our average cost, I don't know, could be about $60. Okay, the least possible cost per headset is approaching $50. Notice that word approaching is there. It's not is $50 because it will never get to $50. It's just approaching $50. The more they sell, the least it's going to cost them to make each headset. Okay, just a little example of how we are going to use asymptotes to interpret data that comes up in the real world. Thanks for watching, guys.